Okay, great. So hello everyone and welcome to Why is the Same Query Sometimes Slow? Everything that I'm going to talk about today, the videos, the demos, the scripts, the databases, is all available at the link that's there on the slide, brentozar.com/go/sniff. So if you need to leave early, you need to miss anything, just grab that URL and that has everything that I need to go cover through the course of today. I am Brent Ozar, Microsoft Certified Master. Whoops, get over on the slide there. Microsoft Certified Master, which just means I've made a lot of expensive mistakes with other people's gear, and now I get to help other people avoid those same mistakes. Got my start as a developer back in the late 1990s and have segued over into working with SQL Server full time. On a topic like this, especially in people who are savvy enough to go to conferences, everybody thinks that they know a little something about this. But buckle up, almost everybody learns things inside this session that come as a surprise. It's really easy to just nod your way through and go, yeah, I got this. And then next thing you know, all of a sudden you don't got this. So make sure to pay attention as we go. There are a lot of small lessons dribbled in throughout the session. It's almost impossible to troubleshoot this without being in production. And there's no single one right answer. This is why you get paid the big bucks, is so that you can figure out what these problems are and how we're going to go about solving them. The good news is that Microsoft is aware of how hard this problem is to solve, and they're starting to take steps in SQL Server 2022 in order to reduce the issue, but it's still there even in 2022. We'll talk about why as we go through it. Inside the span of this session, I want you to learn three things. Number one, what parameter sniffing is. Number two, how to react to parameter sniffing emergencies. And then three, how to fix the code in the database long term to make parameter sniffing less of an issue. Start with number one, what parameter sniffing is. Now in my labs here, I'm working with SQL Server 2019 with the latest cumulative update and the medium-sized version of the Stack Overflow database. It's 50 gigabytes in size. You can go download it for free over at brentozar.com/go/querystack. I like the Stack Overflow demo database because it's real-world data distribution and more real-world in terms of sizes. I'm going to start by taking the users table. The users table holds exactly what you think it holds, a list of everyone who's logged into Stack Overflow, left a comment, left an answer, posted a question, whatever. People at Stack Overflow are very competitive. They're constantly in a race to see who has a higher reputation. So I'm going to run a query. I'm going to say, show me the top 10,000 people where reputation equals some number. It's an integer, starts at 1 and goes up to a bajillion. And then order them for me by display name, kind of like I'm creating a leaderboard here. So SQL Server has to make a decision. Should it use the index or not? When I call it for reputation equals 2, SQL Server has to think about how many people will match reputation equals 2. And then based on how many people match, I'm going to need to calculate a memory grant. See, SQL Server needs to calculate memory grants before your query even starts. It has to figure out how much data you're going to be sorting. So to know that answer, it has to guess at how many people match reputation equals 2. It also affects things like parallelism, how parallel the query goes. SQL Server thinks that if there are lots of users who match, then it's going to parallelize the query. If hardly any users match, it's going to do the query single-threaded. Here's what SQL Server uses in order to think about that decision. VBCC show statistics will tell you what SQL Server knows about a particular column or about a particular index. In this case, that index that I just created, I'm going to ask SQL Server to show me what it knows about that index. DBCC show statistics, totally safe command to run. You can run it in production. It returns absolutely instantly. And it's able to do that because statistics are just one 8K page. It's a really tiny amount of metadata to describe the contents of what we're looking at. Like in this case, we're looking at the index on reputation. At the bottom of that screen, there's something called a histogram. And a histogram sounds really scary. All it is it's a bunch of buckets. SQL Server creates up to 201 buckets to describe how our data is distributed. It puts data into buckets together so that if I ask how many people match a specific number for reputation, SQL Server will go look at those statistics to guess how many rows will match. Now in this example, you see at the bottom of the screen there, it says range high key 1. So there's a bucket just for the people with reputation equals 1. Reason why is that when you create a new account over at Stack Overflow, and this happens all day, every day, when you create a brand new account to go ask a question or post an answer, you get 1 reputation point. Everybody, when they get started, gets 1 reputation point. So it's very common for people to have just 1 reputation point. I have about 2.5 million users as of 2013 for Stack Overflow. And out of those 2.5 million users, 1 million of them only have 1 reputation point. Because the way that a lot of people use Stack Overflow is they go create an account to ask a really crappy question, and then they leave. And then the next time that they come back, in order to ask a new question, they'll just go create a new dummy account, a new burner account, to go ask the new question. So tons of people only have reputation equals 1. On the flip side, hardly anybody has reputation equals 2. Because if you're going to stick around at Stack Overflow, you're probably going to earn a lot more reputation points quickly. If you're the kind of person who wants to go answer questions over at Stack Overflow, you're probably going to answer several questions, or people are going to upvote your questions, except not mine, because I give crappy answers. So there are only about 2,000 people, 1,854 people with reputation equals 2. It's extremely rare. SQL Server uses this histogram data to figure out how it's going to build the shape of an execution plan. So when SQL Server sees this query asking for the people with reputation equals 2, SQL Server decides to use the index. It seeks into reputation equals 2. But because my index doesn't have all the columns that people want for this query, you'll notice that the query has select star in it. It's a whole separate discussion. But because the query has select star in it, we need more columns than are on the index. So SQL Server does a key lookup for every single row that matches. I like to think of key lookups as 3-dimensional. They get executed once for each row that comes back. So as a result, we have to touch that key lookup lots of times because we were going to bring back about 1,800 rows. Notice where the red arrow is. SQL Server exactly estimated the number of rows that were going to come back because he knew that reputation equals 2 matches 1,854 rows. On the flip side, if I turn around and run this query for reputation equals 1, SQL Server doesn't use the index because the number of rows that will come back is higher than the tipping point. It's the point where SQL Server decides it's not worth doing that 3-dimensional operation, touching over and over on the key lookup for 1 million rows that come back. That would be millions of logical reads. SQL Server says it's faster to just scan the entire table once. But scanning the entire table once is going to be some work. So SQL Server decides to parallelize that execution plan. You see parallelism operator in there, and also there's a lot of memory that's involved because we know that we're going to sort 1 million rows. We're going to need a whole big memory grant. Key lookups are expensive, so SQL Server tends not to use them when you talk about big data. There's a concept of a tipping point, where when SQL Server thinks that a large number of rows are coming back from the query, he'll simply ignore the index. And that makes sense for large amounts of data. Both of these execution plans are relatively fast. If I look at set statistics time and I/O on, I can see the number of 8K pages that were read by each of these operations and how much time that they took. The first query that ran, reputation equals 1, did the table scan, so it reads about 5,000. Oh, I'm sorry, the first query, that is backwards. Hold on a second here. Let me edit that slide. Let's go change this real quick, because this is actually oh, did I hit the wrong page? No, that's right. Oh, yeah. No, I'm right. I just have them in a little goofy of an order. Let's put this back in full screen. Make sure you can see that. Okay, good. I get a little panic there when I'm like, no, all of a sudden those numbers are wrong, but those numbers are actually right. So at the top, when I ran it for reputation equals 2, it runs really quickly, and it only does about 5,700 page reads, because it's able to use the index plus do a few key lookups. It doesn't need a big memory grant, and it doesn't need to go parallel because reputation equals 2 is tiny data. Not a lot of people match. Whereas on the second part of this, for reputation equals 1, this query takes longer, 2.5 seconds, which still isn't terrible to a lot of users. But notice that in that 2.5 seconds, it used 6 seconds worth of CPU time because the query went parallel. SQL Server knew that it was going to be a large amount of work to be done, so SQL Server decided to parallelize the query. SQL Server also knew a lot of rows were going to come back, so he did a bigger 400 megabyte memory grant in order to sort all of this data. That's how queries work when you put in literals. When SQL Server compiles an execution plan for that exact string, SQL Server is able to look at the contents of your string and say, you want reputation equals 2? I'm going to build a query plan for reputation equals 2. You're looking for reputation equals 1? I'm going to look for the statistics for reputation equals 1. Stored procedures work a little bit differently. Now, what I'm about to describe through the rest of the session, I'm going to use stored procedures as an example, but you could use dynamic SQL, entity framework, link to SQL, and Hibernate, Dapper. Anything that uses parameters is vulnerable to the problem that I'm about to describe here. I don't want you to think that stored procedures are somehow worse than regular queries. But when I put it into a stored procedure and I take reputation as a parameter, or if I did entity framework and Hibernate, whatever, anything that uses a parameter, and then I say, first run it for reputation equals 2, then run it for reputation equals 1, something different happens with parameterized SQL. SQL Server sniffs the first set of parameters that gets used. In this case, it's sniffing reputation equals 2. And it's building an execution plan that is kind of sort of optimized for reputation 2. SQL Server looks at whatever parameters happen to run first and believes that most of the data distribution will match that. It's optimized for 2, but it's safe, and I use that in air quotes, safe for any other parameters. This one execution plan has to work for everyone. I didn't say run. Sometimes it kind of limps and drags its legs, works a little bit slowly, but it has to at least execute for everyone else. So the first time that the query runs, it gets an execution plan designed for reputation equals 2. The second time that it runs, it also gets the plan that's optimized for reputation equals 2. If I look a little more closely on reputation 1's plan, the second query that runs, if you look at the estimated number of rows, the estimated number of rows, 1,854, is reused from the earlier query's execution. Whatever parameter happened to run first, it sets the estimates, it sets the shape of the plan, it sets the parallelism, it sets the memory grants. SQL Server will keep reusing reputation equals 2's query plan over and over again. Now, those of you who haven't solved parameter sniffing issues before will think that's okay because I used the index. Isn't using an index good? Hold that thought. Continue looking through the execution plan. When I'm doing performance tuning, I like to say that you want to start from the top right operator and work your way through across. Look for the places where estimates versus actuals are way off. And whenever they go way off, that kind of sets the tone for the rest of the execution plan. Here, SQL Server brought back 1 million of an expected 1,800 rows. And because that first operator is way off, nothing else in the plan stands a chance, like the sort. If you look at the sort there says, I actually ended up having a yellow bang on me, which means that I spilled to disk. SQL Server ran out of memory while executing this and decided to spill these results over into TempDB. TempDB is kind of like SQL Server's swap space. Now, this isn't big data. This whole table, it's only like 300 megabytes in size. SQL Server could have easily adjusted up while the query was running. That's not something that SQL Server does, except under some pretty rare edge case scenarios like batch mode execution. Most of the time, when you bring back more data than SQL Server was expecting, like we did here, SQL Server simply says, mercy, I give up. I have no idea how much is coming through here. I better go ahead and stop and drop write this to disk. To understand why, right-click on the select for reputation equals 2, or 1, the second query in the list. Choose properties, and then go look over in the parameters list. This query plan was compiled for reputation equals 2. The current runtime is reputation equals 1. So this query plan might work well for reputation equals 2, but it's being reused for reputation equals 1. Now when I look at my metrics, the numbers are not so good. Now, the first query that runs fine. Reputation equals 2 still runs in way less than a second, and he still does a pretty small number of logical reads. But if you look down at reputation equals 1, sweet potato, it went from taking like 2 seconds to 3 seconds now to taking 6 seconds. Because reputation equals 2 is single-threaded. The plan that was designed for tiny data didn't need to go parallel. Well, reputation 1 needs parallelism, and he didn't get it. So because of that, if he needed 6 seconds worth of CPU time, he took all 6 seconds in order to get that time. Plus, look at the number of logical reads. We're reading more 8K pages than there are in the table. We're reading over 3 million 8K page reads out of an object that's only got like 45,000 pages in it altogether. This is a pretty crappy scorecard because reputation equals 1, when he runs after reputation equals 2, almost all of his metrics get worse. The only metric that doesn't get worse is CPU time, and that's not something that end users care about. All users care about is things like duration, and duration got twice as bad. Logical reads got way worse. Our memory grant was way smaller because we reused reputation equals 2's plan. Now let's just say that someone decides to restart the SQL Server. They decide to rebuild the indexes on the users table. They decide to update statistics. What all these things really do is they clear all or parts of the plan cache. So I know people who are like, I need to rebuild my indexes every single day. They're continuously rebuilding their indexes or updating their statistics, but what they're really doing is taking a bottle and breaking it over SQL Server's skull, making him forget things. And now, just by random luck of the draw, let's say that reputation 1 happens to run first. Now, reputation 1 sets the tone for everyone. Reputations 1's execution plan gets used first. We do a table scan. It goes parallel. It gets a big memory grant. Then when reputation 2 happens to run, he also does a table scan. And you're like, whoa, that's going to be bad. Well, not necessarily. If I go look at metrics, reading the entire table in this case isn't really that big of a deal. Yeah, sure, it is more logical reads, but the query still finishes in about 500 milliseconds. And there aren't a lot of users who will complain about 500 milliseconds. But I tell you what, there are a lot of database people who will complain that the indexes, for some reason, aren't getting used. If I look at the scorecard between these two now, I don't know that this is better for reputation equals 2. It's worse in some cases. I'm doing more logical reads. I'm getting a higher memory grant. A lot of people don't care about that. A lot of people don't care about a high memory grant. But here's the thing. I bet a lot of us out there are database administrators, and we're monitoring a metric called page life expectancy. Page life expectancy is the number of seconds that an 8K page will stay up in memory. And when that number crashes, we think, oh my God, SQL Server can't cache data right now. Some big ugly query must be running. Nah, you know what it really usually is? It's a query that got way too large of a memory grant. And SQL Server decided to clear out all that memory to make room for that memory grant. Whatever memory your query gets granted, it holds on to that during the course of execution. And by default, one query can grab up to 25% of your RAM. So this is an interesting problem for me. There's no one good plan here. I get frustrated when I see people talk about parameter sniffing and they say the good plan or the bad plan. Oh, I wish my life was that easy. I wish there was a good plan for every single query that was out there. But in reality, I usually need a mix of different execution plans in order to make this work. That is what parameter sniffing is. When SQL Server sniffs, the first parameter that gets used after a restart, after index rebuilds, after updating statistics, after a cluster or availability group failover, and SQL Server uses that plan until that next event happens. All right, so number 2, the second thing that I told you I wanted you to learn. I said I wanted you to learn 3 things. Number 1, what sniffing is. Number 2, how to react when it strikes. Number 2, how to react when it strikes. What's up here on the slide is what we do in the course of our career. When we first got started, we said, oh my God, performance is terrible on the SQL Server. I better go restart. And it worked. When you restarted Windows, it worked. Because what'd you do right after you restarted Windows? You went and ran the query that used to be slow, and now you got an execution plan that was perfectly tuned for that set of parameters. And you're like, whew, I guess SQL Server just needs a restart every now and then. Later on, someone slaps your hand and says you're not supposed to be doing that to SQL Server. Good DBAs don't restart SQL Server. So then what do? Well, the next thing you do is go run dbcc free proc cache, which cleans all the plans out of SQL Server's memory. You're breaking a bottle over its head. What do you do immediately after you free the plan cache? You run the query that used to be slow and you fixed it. But you know what? Every other query that you have is now having parameter sniffing issues. They're all playing Russian roulette, saying, guess what parameters are going to come in now? No one has any idea. Same thing with rebuilding indexes. People say, well, if I don't rebuild my indexes and update my statistics every day, I get bad plans. No, what you're doing is you're clearing parts of the plan cache and you're gambling on whatever parameters happen to come in next. It drives me crazy when I see DBAs doing this, rebuilding indexes or updating stats every day. And I go, "What? So did you solve it? Do you never have any bad plans?" And they're like, "No, I still have bad plans. But I rebuild my indexes and update stats every day, and then the bad plans go away every night." Hold on a second here, Speedy. That means that every morning when you come into work, you're facing parameter sniffing issues again. You're the one who's punching yourself every single night. How's about you stop punching for a while and let the plans stabilize? And then when you have parameter sniffing issues, instead of breaking a bottle over SQL Server's head, why don't we just remove the one bad plan from cache? And here's how you do it. What you do is run spblitz cache. spblitz cache is an open source stored procedure. You can Google and get it out of the first responder kit. It's out there on GitHub. What it gives you is a leaderboard of the top 10 most resource intensive queries. Generally speaking, when you're having performance emergencies, when all hell is breaking loose on the SQL server, whatever that one bad plan is has drifted up in the leaderboard. And when you run spblitz cache, you'll look at the top 10 and go, wait a minute, I don't recognize this query as usually getting a bad plan, or I don't recognize this query as usually running so long or burning so much CPU. If you scroll across through spblitz cache's results, and there are free videos out there on how you use spblitz cache, if you scroll across through spblitz cache's results, you'll see things like average CPU and average duration so that you can see how long queries usually take on your SQL server. Now, of course, if you know the query that's having the bad plan, then that's a lot easier. You can even run spblitz cache for one particular query if you want. Over at the far right-hand side of spblitz cache's query results, there's a command to go run dbcc free proc cache for just that one query. We are freeing just that one query plan out of the plan cache. And then go run the query that used to be slow. Look, I'm not fixing anything. I told you that I was going to do three things. Number one, teach you what parameter sniffing is. Number two, how to react when the emergencies strike. Three, how to fix the code or the database long term. We ain't done number three yet. All I'm doing is number two, just figuring out how I'm going to get past the emergency. So when I'm on the phone with the users and I'm like, okay, so you say that this one's really slow. Hold on a second here. Let me just go run this command. Okay, so I've freed out the plan cache. Go ahead and try to run your query again. Then they can then go try to run it again. And if it's fast, I can go, well, all right, I didn't actually fix anything like long term. I just got us past the emergency. Now I got to go fix this long term. Because otherwise, if all you do is free that one plan from the cache, this emergency is coming back. It is only a matter of time before we run into this exact same problem again, sooner or later. So after we've freed that one execution plan from the cache, now it's time to talk about number three in our list of things that we're going to learn. How are we going to fix this thing for good? Normally people just go, okay, great. All I have to do is slap option recompile on the query, and SQL Server will build a brand new execution plan from cache or from scratch every single time. When reputation equals 1 runs, SQL Server is going to build a plan that's optimized for reputation 1. When reputation 2 runs, SQL Server is going to build a plan just for reputation equals 2. I like option recompile. It's actually really cool. There's a blogger and presenter out there, Guy Glancer out of Israel, who has a great way of talking about parameter sniffing. He actually asks for a switch we can use at the entire SQL Server level to say, just force every plan to recompile. We don't have that switch, but it's kind of neat to think about. It's kind of how MySQL and Postgres work. They don't really cache execution plans the way that SQL Server does. But SQL Server, building an execution plan is computationally intensive because there's a lot of work to do while we're building an execution plan. You can see that work if you go into the execution plan, right-click on the select, and click Properties, and look up at the top over in the Properties pane. Near the top, there's going to be something that says Compile CPU and Compile Time. These are measured in milliseconds. So it gives you a rough idea of how much CPU time SQL Server spent building that query. This that's here on the screen is a really simple one-table query that only took 11 milliseconds for SQL Server to compile a plan. When we're thinking about the kinds of queries that we've been running so far today, 11 milliseconds is nothing. But when you put in a more real-world execution plan or a more real-world query, something that's more complex, it calls functions, it has joins out to other tables, then we're talking about hundreds of milliseconds in order to compile a query. To you and I, hundreds of milliseconds sounds cheap. But think about it at scale. If you only want to run 10 queries per second. 10 queries per second isn't a big number. 10 queries per second is a tiny number. If you only want to run 10 queries per second and each of those queries takes 300 milliseconds to compile a query, that means you need 3 CPU cores just to compile the queries. I haven't even started running the queries. I'm only compiling them. So the problem that you run into when you start using option recompile is developers get a feel for how powerful it is and they start slapping it in everywhere like butter. They're just like, slap some option recompile on it, it'll go faster. And then next thing you know, your CPU usage is getting higher and higher, and no one knows why CPUs are totally on fire, because it's really hard to see this inside of SQL Server, to see that it's spending so much CPU time compiling queries, and then you spend a lot of money on some out-of-town consultant who wears t-shirts and jeans and gets on a video call. I like option recompile. I like it a lot, but I want to use it only in surgical strikes where it's really important and the query doesn't run very frequently. Generally, my guidance to clients is that if a query runs once per minute or less often than that, then sure, option recompile is totally fine. But if a query runs more than once a minute, hold up. We need another way in order to solve the problem. I need a way to solve the problem that isn't going to drive my CPU to 100%. The options that I'm about to describe for you all suck. It's not like option recompile is the only one that sucks. They all suck. And when I give this session in person, I see people with their pens hovering over their paper, waiting to hear the one option that doesn't suck, and they're going to start writing this down. This is why you get paid the big bucks, is that you have to actually figure out which one of these problems sucks the least for you. SQL Server 2022 starts to introduce fixes for the problem that I described earlier in the session. I would argue that just instantly upgrading to SQL Server 2022 is also a problem that sucks. Plus, it only solves the one specific problem that I showed earlier in the session. It doesn't do things like problems with start date and end date, or lots of different parameters. It settles on just a couple few with big, huge outliers, which is good. It's still better than nothing. It's better than us having to deal with this all the time. These are the options that we have to deal with, and I'm going to walk through each one of them. And the first decision that you have to make is, can I get one execution plan that works well enough for everyone? It doesn't have to be perfect, it just has to work well enough. Or do I truly need to cache multiple different execution plans? I'm going to start with the first set, getting one execution plan that's good enough in our environment, because those are generally the easier ones. One of the options that you can use is with Recompile. You can tell SQL Server, go put Recompile on this stored procedure so that every single time the stored procedure runs, build a brand new plan from scratch. Never, ever, 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 ever put Recompile on the outside of a stored procedure. When you put Recompile on the outside of a stored procedure, SQL Server never remembers that that query has been run multiple times. What you want is option Recompile at the statement level. If you've got to use Recompile, use hints at the specific statement that's having the problem. This is especially important when you've got those big, long stored procedures back at the office that have like a gajillion statements in them. Go find some data from a configuration table. Go run a function. Go set up a temp table. Go find the exact statement inside there that's having the parameter sniffing problem and just put option Recompile there. That way, the rest of the execution plan remains stable, and SQL Server is going to start caching how often the whole thing runs. Now, some of you, I'm going to back up a few slides. Some of you are going to be like, wait, Brent, I've opened up your first responder kit and I've seen that you do this with a Recompile on the outside. Okay, yeah, so that's true because there's one good use for Recompile. All of a sudden it looks like my video bombed out. There it goes. There's one good use for Recompile on the outside of a stored procedure. That's when you want to hide your code from monitoring tools. I get really frustrated with hearing people say, Brent, I ran SP Blitzcache and it shows that the most resource-intensive queries on the server are from SP Blitzcache. Well, yeah, buddy, that's because your server's completely bored. There's nothing going on it. Nothing has happened in your development server in the last 3 years. A, you need to get to work and start actually developing things. And B, I'm tired of those support calls. So I'm going to put with Recompile on the outside to just kind of camouflage that SP Blitzcache even runs, which is kind of fun trivia that you might enjoy as well. The next way that you can get multiple execution plans is to do branching inside of stored procedures. You can say, if reputation equals 1, go run this other stored procedure. Otherwise, if reputation is anything else, go run this other stored procedure. This looks so weird, but the magic of building a plan is that when this stored procedure gets run, it'll get optimized for whatever reputation number, but not the child stored procedures. The child stored procedures will only get optimized when they're called. And when they're called, they will get sniffed with whatever parameter they happen to get executed for. So that users by reputation 1 stored procedure will get sniffed for reputation 1, and SQL Server will build the big data plan for it. The users by reputation other stored procedure will also get sniffed. It'll get sniffed for some other number, and I'm still going to have parameter sniffing issues over there. But as long as my data distribution is pretty evenly distributed, I might call that my small data execution plan, and it'll get optimized for the index seek plus key lookups. This is technical debt. When you put this in, you better know what number to go branch on. And what if Stack Overflow tomorrow decides to embark on a feel-good project where they're going to give everybody more reputation points just for starting their account? What if instead of just giving people 1 reputation point, they give people 100 reputation points? Well, I'm going to have to go back and revisit my code, so I have to be aware that that's technical debt. Next option that I have is a hint in the query called optimize for unknown, which is kind of like a blindfold. It tells SQL Server, I don't want you to do parameter sniffing at all. I want you to optimize this query as if you didn't know what parameter was coming in. SQL Server at that point will optimize for the average reputation. It uses a value out of the statistics histogram called the density vector that says, on average, what percentage of the table is occupied by any given reputation number. Well, reputation numbers are all over the place. Some people have reputation 30,001. Some people have reputation 30,002. The data is really widely spread out. So as a result, the average number only estimates 123 rows. That's not good for either of my parameters. That's not good for reputation equals 1 or reputation equals 2. They both spill to disk in that case. Neither of them get parallelism. They get a tiny memory grant. The only place where this works is when your data is really evenly spread out. Wait a minute. If your data is really evenly spread out, why would you have parameter sniffing problems? Well, you wouldn't. But still, this works if I wanted to say, I don't ever want to build the big data execution plan. This should never be called for reputation equals 1. Reputation equals 1 is a screwball number. For example, maybe this report is being run by competitive people at Stack Overflow, and they don't give a rip about those people with reputation equals 1. This could work because it's going to influence the small data plan. But if you're ever going to call reputation equals 1, it's probably not a very good idea. Next up is declaring a local variable at the top of your code. When you declare a local variable at the top of your code and then you set it to be the same as the outside variable, SQL Server has no idea what the contents of that variable will be at runtime. So it acts exactly the same as option optimize for unknown. SQL Server uses the density vector out of statistics and says that the average number for reputation has 123 people in it. Never, ever, ever, ever do this. Right about now, some people in the audience are like, wait a minute, that's what I do. I know, you need to stop. Because when you do this, people don't understand what your code is doing and they rip your fix out. They look at your code and they go, what kind of moron would set in a variable and then set the contents to be the same as itself? This doesn't make any sense. They rip your code out and they destroy your hard work. I don't want you to look stupid. I want you to look smart. And when you look smart, people don't touch your code. So when you put in option optimize for unknown, the less experienced people who see your code go, oh, I've never seen that hint before. I better not touch that. And so as a result, they keep your code fixes in place. That's what I want. I want them not to screw up your hard work. So don't do the stupid local variable trick. That's been out of phase or out of popularity for 15 years now. You probably should go to training classes more often, but that's another discussion altogether. If you want the density vector, just put in option optimize for unknown instead. Related to that is optimizing for a specific value. I love this. If there is one value that works well for everybody, you can hint that inside your code. For example, here, I'm saying, don't worry about whatever variable comes in. I always want you to optimize for reputation equals 1. This is kind of cool because it gives me a stable execution plan no matter when the SQL Server restarts or when the indexes are rebuilt. But it is technical debt because, again, what happens if Stack Overflow changes their starting point for reputation and they go for, instead of having reputation equals 1 as the starting point, they give everyone 100 reputation points? I'd have to go back and revisit my code. What if I optimized for a specific user and then that user deleted their account or stopped being active or suddenly became very active? I got to be careful about hard coding numbers inside of there. Next solution is plan guides, where I get exactly the execution plan that I want, and I leave it behind as a hint for SQL Server. Plan guide hints are kind of like hints that your partner gives you. It's like, you should probably check out the trash, or the trash is starting to smell. It's not really a hint, it's a command for you to go get down there and go take out the trash. A plan guide works the same way. It's kind of a hint to SQL Server. Whenever you see this code, apply this exact query plan. And it works about as well as hints from your partner. We don't always pick up on that, sometimes until the trash is overflowing and it's stinking, and also I need to take out the trash. Plan guide hints don't always work, and whenever the query changes, like if someone changes the contents of a stored procedure or adds a join to a query, adds a column to a query, that guide will no longer work. SQL Server will be like, I'm looking for this exact query over here, but this query, I can't use that plan guide because it is literally a different query. I don't mind plan guides. They're fine. Once you get them to work, it's totally okay. But the problem that I have with plan guides is that they'll time bomb out as soon as the query changes. So I think of plan guides as kind of like duct tape. It'll get me home, but I'm going to have to figure out some other solution long term, like putting some kind of hints in the query, because that query is inevitably going to change. The hardest solution is to get a better execution plan for everyone. And I say it's hardest, it's not really that bad, but when you see parameter sniffing issues, one of the top causes for that is where SQL Server has to decide between an index seek and a key lookup versus scanning the entire table. The SQL Server is making the decision between those two. Sometimes I can help it by creating a better index that just simply works more across more scenarios, or changing the code. I say it's a harder issue because when I do query tuning, I keep a little, well, for some reason my monitor went up. For some reason, whenever I talk about query tuning, I use a half-hour hourglass. I have a half-hour hourglass that I keep next to my desk. And so whenever I'm doing query tuning, I'll flip the half-hour hourglass and set that on my desk. Inside the span of that half an hour, I need to find the parameters that are causing the problems, run them to get the actual plans. I need to come up with a hypothesis as to what would be a better way to run the query. Sometimes it's with index changes, sometimes it's with query changes. I need to put that hypothesis into place, and then I need to run the queries again to see whether or not my fix actually improved things. Sometimes with real-world queries and real-world data sizes, it's hard to pull all that off inside the span of half an hour. Whereas things like option recompile just feel quick and easy because you can slap it on and not have to worry about query results. Everything just magically works right away. So how about in the case of the demo query that we've been working on so far? What are the right answers? And it's not black and white. There are lots of ways that you could fix this. At the beginning, option recompile. Would this work? Sure, if the query isn't run that often. If it's run once a minute or less frequently than that, sure, just put an option recompile hint on it and call it a day. And I know a lot of managers and database administrators get all nervous when I say that, but at the end of the day, development time is really expensive, and option recompile is relatively cheap for queries that don't run that often. Personally, I would love to have an option called cost threshold for recompile. If a query cost more than this much query bucks, just go recompile it every time. Because after all, if the query costs 1,000,000 query bucks, I need to spend a little bit more time before I go and execute it. And it's not like I got 1,000,000 queries per second running that all cost 1,000,000 query bucks, because my server would fall over, it wouldn't be able to keep up. Knowing the success rate of other things that I've asked for Microsoft, and my public request is out there for cost threshold for Recompile, I estimate that that will never get worked into the product, especially since Microsoft has this attitude that you're not even supposed to have to touch cost threshold for parallelism. They keep wanting to say the SQL Server is self-tuning, and every time I turn around, there's a SQL Server on fire and I'm getting paid to fix it. Why am I complaining again? I don't quite remember. Second option on there, stored procedure branching. I could put in a parent stored procedure that says if reputation equals 1, go call the big data stored procedure. If reputation equals 2, go call the small data stored procedure. Both of them would have exactly the same contents. This would work beautifully in my case as long as whatever if logic I used, like if reputation equals 1, was permanent. And by the time that you hit parameter sniffing issues, usually the data is pretty stable and you can solve that kind of issue with that technical debt. That works great in this case. My developers get a little nervous and start itching and scratching because now I have the same exact query stored in 2 different stored procedures, so they got to know to change both of them whenever they update one. That's a lot cheaper than having to deal with a parameter sniffing emergency all the time. Next, under the single plan options, optimize for unknown, or the old local variable trick. That doesn't work worth a damn here in this case. Now keep in mind that I'm describing a whole set of tools. I always think of myself as like a carpenter because I break my fingers. I think of myself as a carpenter with a whole set of tools out here. Just because one of the solutions on this slide doesn't work for this query doesn't mean it wouldn't work for another. In this case, the option optimize for unknown doesn't help me because the estimate is so low, so I can scratch that one off. Optimize for reputation equals 1 does work in the sense that for my users, performance is fast in both cases. Sure, as a database administrator, it kind of bugs me that I don't get index usage and that reputation 1 is going to scan the whole table every time, and that it's going to get a larger memory grant, but those memory grant sizes aren't catastrophic, and the users table isn't all that large, and I don't mind scanning it. I just want to know to make that decision so that when someone comes to me and says, hey, why isn't reputation 2 using an index? I can say it's because I had to hint the query so that it just always does a scan to avoid parameter sniffing problems. A plan guide would work as long as I can pick one query plan that works well for everybody, which is exactly the same as option optimize for 1. I would optimize for the table scan plan. I wouldn't optimize for the index seek plus key lookup plan because of the problems that happens when that thing runs for reputation equals 1. And then finally, get one good execution plan for everyone. There's an easy fix for this particular query. I created an index on just reputation, but my query says for one reputation, sort them by display name. What I really need to do is create a wider index on reputation than display name so that SQL Server could seek into reputation equals 1, and then they'd all be arranged by display name. Then both versions of the query would go faster. If you were watching carefully on the execution plans through the session, you'll notice that Clippy's recommended missing index didn't specify that. Clippy just said, hey buddy, I want you to create an index on reputation that includes all of the columns. Well, okay, that's certainly one way to solve it. Everything that I described in here today is doable. There are harder problems in SQL Server. Row goals and spin locks come to mind. This is doable once you know the term parameter sniffing. Then it's easy to understand A, what parameter sniffing is, B, how to react to emergencies, and then C, what your different options are for fixing it long term. In terms of tackling the emergencies, go look at SP Blitz Cache, sorting by which queries are the most resource intensive, find the query that has unusually bad execution plans, and then just do a targeted strike. Free that one execution plan from cache and call it a day. Then you've got to go back and start working on making that query less susceptible to parameter sniffing long term. And then we talked about 7 ways that you can do that inside of this session. There are more. Things like dynamic SQL with comment injection is one of my favorites, but it's beyond the scope of something that I can teach inside an hour here. So to learn more, go check out at brentozar.com/go/sniff, where I've linked to way more resources and videos, including an excellent 50-page long article by Erland Sommerskog called Slow in the App, Fast in SSMS, that goes into much more details about how parameter sniffing happens, ways that you can work around it, and much more. So thanks for hanging out with me today at SQL Day. By all means, please to go over the polls tab of the session and tell the organizers how you felt about the session and me. It's not that I care. I don't give a damn what you think. But I just want you to be able to voice your opinion so that you can help influence other presenters, because they still care about what you think, not me, as to how they can get better. As a presenter, I don't care very much about like high ratings. What I care about is if there's something that you didn't like, tell me so that I can maybe work on that for next time. Pavel says over in the questions, Pavel says, what do you prefer, to just write stored procedures and wait till sniffing occurs, or try to guess? By all means, I'll tell my developers, don't even think about parameter sniffing. Write code. Because we don't even know which of our code is going to be popular. You know how it is. People will ask you to write features, and then they never actually use those features inside the application. They'll go off and use something completely different, or they'll use it in a way that we totally didn't expect. So circle back and solve parameter sniffing issues later when the code is popular and the data distribution has stabilized. Because in the beginning too, when you're writing applications, you have no idea what the final data distribution is going to look like, and it'll change over time as well. So I've got that one. I'll mark that as answered and then see if I didn't miss anything over in Q&A. Okay, perfect. So thanks a lot for hanging out with me today at SQL Day, and I will see y'all. I have a session tomorrow, why defragmenting your indexes isn't helping. So I'll see y'all in that session. Adios.